So bulk modulus, we know that bulk modulus, it is given by B is equal to volume stress by volume strain. Okay, now volume stress is due to the weight that, so volumetric stress is mg divided by A is the area, strain, that is change in volume or original volume, so that is dV by V. Okay, so now I can write it as B is equal to mg divided by A dV by V. So that gives dV by V is equal to mg by A into B. Okay, now in this case, in the question, bulk modulus is given to be K, so let me write it as A into K. Okay, so this is dV by V. Now volume of sphere V is equal to 4 by 3 pi r cube. Okay, so that means dV is equal to 4 by 3 pi 3 r square into dr. Okay, so that gives dV by V is equal to 4 by 3 pi 3 r square into dr divided by 4 by 3 pi r cube. Okay, so this 4 by 3 pi, 4 by 3 cancels out, this r cube, r square, this cancels out, so we have 3 dr by r. Okay, so that means the fractional change in volume is 3 times dr by r. So this can be replaced here, so we have 3 dr by r is equal to mg by ak. Okay, so that gives dr by r is equal to mg by 3 ak. Okay, so that is option number 2 for question number 87. So for question number 87, the correct option is number 2. Next is question number 88. You have a granite rod of length 60 centimeter. It is clamped at the middle and there are longitudinal vibrations in the rod. Density and Young's modulus is given and you are asked to calculate the fundamental frequency. Okay, so now if this is the granite rod and if it is clamped at this point, okay, so these two are free ends, so free ends will have antinode and this point will have node, so the vibrations will be like this. Okay, so that this distance is lambda by 4, this distance is lambda by 4, so the entire distance in terms of wavelength it is lambda by 2 and L is the length of the rod, so that gives L is equal to lambda by 2. Okay, or I can write lambda is equal to twice L. Now frequency is V by lambda, correct? Now what is V? V is the velocity of wave in a rod. Okay, now that is given by square root of Young's modulus by density. Now in the question, Young's modulus and density are already given. Now if you substitute the values of Young's modulus and density and if you calculate this, you will get the value as 5.85 into 10 power 3 meter per second. So this is the velocity of the wave in the rod. Now if you substitute this value over here, so this is 5.85 into 10 power 3 divided by lambda. Lambda is twice L, so 2 times length of the rod. Length of the rod is 60 centimeter, so that is 0.6. Okay, now in calculating this, we get the answer approximately equal to 5 kilohertz. So for question number 88, option 4 is the correct answer, 5 kilohertz. Now next is question number 89. The mass of hydrogen molecule is 3.32 into 10 power minus 27 kg. 10 power 23 hydrogen molecules are striking per second on a fixed wall of area is given, angle is given, and speed is given with which the molecules are undergoing collision. The pressure exerted it is asked. Okay, so see, this is the wall. The molecules are undergoing collision at angle 45 degree. They are going like this. Okay, so the pressure on the wall is due to the collisions. Okay, so now pressure is force per unit area. Okay, so in order to calculate the force, pressure, I need to calculate the force. Now force is rate of change in momentum. Okay, so now this is rate of change in momentum is force. So pressure is, so 1 by area into dp by dt. So this is the pressure. Okay, so the change in momentum, see, this is mv. So that means the momentum is, this direction is mv. Okay, this angle is 45 degree. So this angle is 45 degree. So this is mv cos theta, cos 45 degree, and this component will be mv sin 45 degree. So this is the momentum before collision. Okay, now after collision, this is mv, it is elastic collision, and this angle is theta. So this theta is 45 degree. So this is mv cos 45 degree, and this is mv sin 45 degree. Okay, so that means the total change in momentum along the wall, it is 0, and total change in momentum perpendicular to the wall, it is twice mv cos 45 degree. Okay, now it is given that 10 power 23 hydrogen molecules are striking per second. So dp by dt is twice mv cos 45 degree multiplied by n. Okay, the n, where n is the number of molecules striking per second. So if you substitute all these values over here, you have 2 mv cos 45 degree into n divided by area. Now all these quantities are given in the question. Now if you substitute the values, we get the final result as 2.35 into 10 power 3 Newton per meter square. Okay, so this is the final result. So the correct option is number 4 for 89. For question number 89, option 4 is the correct answer. So this is question number 90 of code C. You have an arrangement of 7 discs, each of mass m, radius r. Okay, so you are asked to calculate the moment of inertia about this point passing through point P, which is at a distance 3r from O. 3r, this distance is 3r. All these are of disc of radius r. So you have to calculate the moment of inertia about this point, and the axis is passing through this point and perpendicular to the plane of the paper. Okay, so we will be using the parallel axis theorem. So first of all, we will calculate the moment of inertia about this point, I naught. So that is, moment of inertia of the disc is mr square by 2 of this disc, plus there are 6 discs, so 6 times mr square by 2. But for these discs, the distance from this point is, I am using parallel axis theorem, so this distance is twice r. So mr square by 2, moment of inertia of this disc, plus m into twice r square. 6 discs are there, so 6 into this. So this gives the moment of inertia about this point. So moment of inertia about this point, about point P, Ip will be again parallel axis theorem. So that is I naught plus, there are 7 such discs, so 7 into m into 3r square. This distance is 3r. So on, if you have to substitute this value over here, I naught is substitute over here. So the final answer Ip is 181 by 2 mr square. So for question number 90, the correct option is option number 3. Option 3 is the correct answer.